AP Calculus AB Function Analysis Analytically. Now, this is going to be a homework help problem, and consequently I'm not going to do all 5 of these problems. I'm going to pass problem number 1 and try to tackle problem 2. And all these 5 problems we're going to evaluate from these 5 aspects. For 1 through 5, determine all critical numbers. Well, critical number, we find where the function's derivative, first derivative, is undefined or it's equal to 0. So we're going to find the first derivative by saying y prime is equal to 3x squared minus 12x minus 12. And we're going to factor out our greatest common factor, which is going to be 3. So 3 times quantity x squared minus 4x minus 4. And so we can set this first derivative equal to 0. And for that, we're going to try to solve by factoring. Not exactly sure how this will work out. We have x and x, and our factors of -4 that add up to -4x. I'm not sure if we can do that. Let's see, that's right. Everything looks right. We may have to resort to our quadratic formula, since this doesn't look like it's easily factorable, because we have -4. What if we take -2 and +2? Well, that's going to be a difference of squares. But then -2 and -2, no, that's not going to work. Then we take 4 and 1. We'll have 4, but then we're going to have -5. So, let's go ahead and apply the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac over 2a. Okay, that's going to be a is 1, b is -4. So x is -4 plus or minus square root of b squared, which is -4 squared, minus 4 times 1 times -4. So all over 2a, 2 times 1. So we have x equals 4 plus or minus, we have -4 squared is 16, and we have -4, so we're going to have the square root of 32 all over 2, which equals 4 plus or minus square root of 32 is, we can pull the 16 times 2. So if we pull out our 16 from this, we're going to have 4 square root of 2 all over 2, which equals 2 plus or minus 2 square root of 2. So those will be our critical numbers. So for that, we're going to write our 2 minus 2 square root of 2. Let's see, 2 plus 2 square root of 2. That's going to be, well, we'll just put down what they are. So this will be 2 plus 2 square root of 2, and this will be 2 minus 2 square root of 2, and let's see, we have in our, if we go to the far left, less than, we're going to put y prime up here and y down here. So we take a value of less than 2 square root of 2. Let's say we have negative 10. That'd be 10 squared minus, that'd be 100, and negative 10 is going to be negative 4 times, going to be positive all the way. We should get a parabola if we look at this. If we go in between, if we pick in 0, well, we're going to get negative 4. So that'll be negative. And then to the right again, if we use a real high number, we're going to have, if we use positive 10, we get 100 minus 40 minus 4. That's going to be positive. So anyway, where the function has relative extrema and so forth is, okay, function, we'll say y is increasing on negative infinity to 2 minus 2 square root of 2, and it's 2 minus 2 square root of 2, and 2 plus 2 square root of 2 to infinity, because y prime is greater than 0. Y is decreasing on 2 minus 2 square root of 2 to 2 plus 2 square root of 2, because y prime is less than 0 on that interval. Okay, all right, y has relative max at x equals 2 minus 2 square root of 2, because y prime changes from plus to minus, and y has relative minimum at x equals 2 plus 2 square root of 2, because y prime changes from negative to positive. Okay, other things here: determine intervals where function is concave up or concave down, justify. Well, for that, we're going to come to this. I'm going to leave some room by erasing our quadratic formula thing here. And for that, I'm going to say y prime, or say y double prime, is equal to 6x minus 12. So determine intervals where function is concave up, concave down. We set this equation equal to 0. 0 equals 6x minus 12. So if we solve, we add 12 to both sides. X is going to be equal to 2. So that's going to be right in the center of our number line we've already drawn. And I'm going to try to sneak in a number line right here with the concave up, concave down. So I'm going to put y double prime here and y down below. And we have 2 is going to be our possible point of inflection. And as we go to the left, we use this function here. We take a number less than 2, say 0. Well, 0 minus 12, that's negative, so we're going to have concave down from negative infinity to 2. And we use a number greater than 2, let's say 4. 6 times 4, 24 minus 12, we have concave up. And so to write our statements down here, we'll say y is concave up on 2 to infinity because y double prime is greater than 0. And y is concave down on negative infinity to 2 because y double prime is less than 0. And then the last part E, is there a point of inflection? Yes, there is a POI at x equals 2 because y double prime changes from negative to positive. Okay, so that's A through E on problem number 2. Okay, 3, 4, 4. I think I want you to do just A, B, and C on number 4. Okay, number 5. We have f of x equals x squared minus 4 over x plus 2. And it would help if we understood what this is. This function is going to be a difference of squares in the numerator. So we're going to have x minus 2 times quantity x plus 2. And on the bottom, we're going to have x plus 2. So our function is going to look like essentially x minus 2. And so critical number is definitely going to be where x equals negative 2. But let's go ahead and work through the calculus on this. Okay, we're going to have high. I'm going to say d high because we already know what high is. D high equals 2x. D low equals 1. So f prime of x equals low, which is going to be x plus 2, d high, which is 2x, minus high, and high is x squared minus 4, and d low is 1, all over quantity x plus 2 squared. So we're going to have, multiplying out, we're going to have, let's see, 2x squared, 2x squared plus 4x minus x squared, and minus minus will be plus 4 all over quantity x plus 2 squared. And just working this out, we have x squared plus 4x plus 4, and at the bottom we have x plus 2 squared, and we work this out. First of all, the function is undefined. The derivative is undefined at x equals -2. So a critical number, one critical number, is x equals -2, just from this. Now, if we work this out, if we expand the bottom, we have x squared plus 4x plus 4, and the denominator we have x squared plus 4x plus 4. And what happens when we make this division? 1. So f prime of x is 1. So determine all critical numbers. We have x equals -2. Determine intervals where the function is increasing, decreasing. Well, function b, function is increasing on, we have -infinity up to our critical number -2, union -2 to infinity, because f prime of x is greater than 0. Determine interval, okay, that's right. Determine where a function has a relative local extrema. There's no local extrema. We have a whole, we have a function that looks like this. Comes from -infinity, goes up to infinity, so no relative extrema. Justify each, then find the value of each extrema. There's no extrema. Determine intervals where function is concave up, concave down. That we have 0. That's not relevant. Now, one thing I didn't do on this one up here, it says determine, then find the value of each extrema. We did not do that. Okay, to find the value of each extrema, we have to plug 2 minus 2 squared of 2 in for x up here, and 2 plus 2 squared of 2 in for x, and that's how we'd find local extrema. Anyway, this is a homework help video. I hope it has been somewhat helpful to you. Good luck on your other problems there, and thank you for viewing.